Hey everyone, this is your first video, me being gone. I'm actually going to do some skipping around in this chapter. So I know we've done 5.1, so we've completed chapter 5, lesson 1. You did some homework at the beginning of today. I'm going to skip all the way to lesson 5 of chapter 5. Because we've been talking about the left Riemann sums, the right Riemann sums, and then the mid Riemann sums. So we've done the LRAM, the RRAM, and the MRAM. And I would like to, since we started our conversation about Trapezoidal Rule last week, I would like to continue with that conversation. Because of all the snow, I thought I would be a lot further along than this when I went on my trip. So we're just going to do the trapezoidal rule, the Simpsons rules while I'm gone, and then we'll pick up integrals again when I get back. So if you will, turn to page 289 with me right now. You can see that the trapezoidal rule approximations start on page 289. You can read that page if you would like to. If you turn to page 290, this is what we looked at the other day. We looked at the equation for the trapezoidal rule and talked about why, what the H stood for, what the 2 was there for, and why y subscript 0 plus 2y subscript 1 plus 2y subscript 2, so on and so forth, and then you had y to the n, y subscript n at the end. And we talked about why there was only one of these at the ends, and then these were counted twice. Remember, if you make a trapezoid and we have that regular curve going on there, let's say that it's y equals x squared, and I did a trapezoidal rule where you're going to make trapezoids going up through here. And we talked about how this was a base, and this was a base, this was a base, and this was a base. And if I'm going from 0 to 3, how this base would be counted once in this trapezoid, but then this base would be counted once in this one, and then another time in the blue one. And then if I had a green trapezoid, so the ends here, these bases were counted once a piece, and then these bases would be counted twice, because they're counted in the red and the blue, and then the other ones counted in the blue and the green. So that's why those factors of 2 are there. And you can read on page 289 what that H is made up of. We kind of did that intuitively at first, so that should give you a better understanding of what's going on there. And this is why I'm making this video, because I want to explain something that I would like for you to skip over until I get back. So at the top of the trapezoidal rule, you have this, and I'll come to this in just a second, but the integral of f of x dx from a to b. So all this is saying is that a is your lower interval and b is your upper interval. So if I had from a to b on the one I just erased, if I did y equals x squared and I was going from 0 to 3, so 0 to 3 would go 0 to 3. F of x would be the function that I'm using, and then dx. dx is something that I'll talk about Thursday when I get back. But 0 to 3 is just this interval. Okay? So you can look at that method, or that rule there. Read through page 292 where you see Simpsons Rule. On page 292 you have Simpsons Rule, and what Simpsons Rule does, instead of rectangles and trapezoids, Simpsons Rule does a parabolic curve to estimate the area. So you can imagine how much better the approximation will be if it's a parabolic shape as opposed to a rectangle or a trapezoid. So on page 292, when you read Simpsons Rule, it's the same way as a trapezoid in a way, because you have y subscript 0 plus, and then you have 4y1 plus 2y2 plus 4y3. You can see how it alternates, and then at the end it ends up with just being 1 again. We're not going to go into the proof of that. Google it if you want to. It's pretty cool proof, but you can watch a video if you want to on that, but just memorize that one. But notice it does say it has to be an even number of subintervals. Okay. So do not read page 293, the error analysis. You do not need to read that. So turn to page 295 with me. And this is where I'll start this video here. On page 295 it says in exercises 1 through 6, A, use the trapezoid rule with n equals 4 to approximate the value of the integral. B, use the concavity of the function to predict whether the approximation is an overestimate or an underestimate. And finally, C, find the integral's exact value to check your answers. So what you are required to do on page 295, I want you to do 1 through 6, but you're only going to do A and B. You are not going to be able to find the exact value of an integral. You are not going to be able to do that. So anytime on any problem that I give you that it says find the exact value of the integral, you're not going to be able to do that. So just skip that part. So what this says is that you're using n equals 4. If you notice, this is on number 1. It says n equals 4. So the function y equals x, right here's your function, remember, f of x. That is that function. And you're going to go from 0 to 2. And you're going to do 4 subintervals. So you're going to have one at a half and then one at 1.5. And you're going to use the trapezoid rule. So you're going to find the value of h, you're going to divide by 2. You're going to use one base here, that base twice, that base twice, that base twice, and that base twice. And find the area. Now, if you think about that, when I draw those trapezoids, that really is going to be the exact value of the integral because that's a straight line. That diagonal on that trapezoid is going to fall on that function every time. So it is actually going to give me the exact area. But I want you to show all the work for the trapezoid rule. So for example, if you look back at your formula, it's h over 2, and h equals b minus a over n. B is going to be your 2, a is going to be 0 from here and here, and then n is going to be 4, and that's going to reduce to a half, which we talked about last week. This is a half. That's actually the height of your trapezoid. Okay. Excuse me, I have the wrong notation there. That's not h. It's actually h over n. No, excuse me, that is. Sorry. So h equals b minus a over n. So you have a half is your h value. So in the trapezoid rule, you have h over 2, and then y subscript 1 plus 2y1, so on and so forth. So I want to back up here. Y subscript 1 in your notation is going to be f of 0 plus 2 f of 1/2 plus 2 times f of 1 plus 2 times f of 1.5 plus 2 times, nope, not 2, plus f of 2. So f subscript 0 is this height, or excuse me, f of 0 is this height. This is f of 1/2. This is f of 1. This is f of 1.5. And then this is f of 2. So notice f of 0 and f of 2 are only used once, and then these bases happen twice. So how are you going to put in h? H here is actually going to turn into a half. So a half divided by 2. And you can do that. I think that's going to be a fourth. It will be a fourth. So a fourth times all of this. Okay. Right, and that's how you do the trapezoid rule. And you're actually going to do this and get all the calculations, but make sure that I see all of this. This is more important to me than you actually getting the question right, is to actually know what you were trying to plug in. Okay, so that's the trapezoid rule for number 1. Check your answers in the back of the book. You're going to do that for 1 through 6 with a sub-interval of 4, or n equals 4. So on number 7, I wanted to go over that one with you, and then you should understand the rest. It says a rectangular swimming pool is 30 feet wide and 50 feet long. The table below shows the depth, h of x, of the water at 5 foot intervals from one end of the pool to the other. Estimate the volume of the water in the pool using the trapezoidal rule with n equals 10 applied to the integral. So all that I want to go over there is that this is going from 0 to 50, meaning it goes from 0 feet to 50 feet. That's how long the pool was. It's 30 feet wide. So those two things are going to stay standard. It's 50 feet long and 30 feet wide. But the h of x, which is the height or the depth of the water, is changing as I go across the pool. So what it wants you to do is actually estimate the volume. You're going to do that the same exact way. You're just going to do 0 to 50, and you're going to do h of x, but you're going to multiply everything by 30. Because think about it, on this one, I actually found the approximation of that. So if I can find the approximation of that, and then I know that that's 30 feet wide, I can find the area and then multiply it by 30. Okay? So I know that's pretty vague, but just know this means I'm going from 0 to 50 feet, and h of x is the depth of the water. Okay? And that one's going to be in the back of the book. So check your odds in the back. So what I would like you to complete is page 295 through 296. I would like you to do 1 through 8. Excuse me, 1 through 10. And on 10, you can only do part A. And then I want you to do 12 and 13. Okay. If you'll do those, we will go over those when I get back. Make sure you do have those completed. I have also put 2 videos for the Simpsons Rule and Trapezoid for you to watch. I will not be checking my email throughout the day, but I will check it at night. If you want to send me questions that you have, I will try to answer those either in a video or respond back to you. So email me daily. Let me know what's going on so I can keep up with you guys. Hope you have a good week.